Hi, this evening we're going to be discussing 3 myths about passive house and natural materials. We're going to start with a few quick intros to both ACAN and our expert panelists. Each speaker is then going to give a short myth-busting presentation and we'll end with a 15-minute Q&A session. So as I mentioned earlier, please feel free to introduce yourself in the chat. And please post any questions that you have for the speakers throughout their presentations. We'll monitor the chat as the event goes on, and we'll try and answer as many questions as we can during the Q&A session at the end. So in terms of timing, we're going to try and keep this to a 45-minute event. And I'm now going to hand over to Aurora, who's going to give a quick introduction to ACAN.
Thank you, Steph. Hello, everyone. So just a quick intro to ACAN for those who might not be familiar with the organization. ACAN stands for Architects Climate Action Network, and it is an open voluntary network of individuals in the built environment industry. It was formed in April 2019 and has now grown into a global network of over 3,000 people. It started with a vision of how we could work autonomously as a collective of individuals in order to make rapid decisions and respond quickly to the climate emergency. And so our manifesto has 3 overarching aims: decarbonize now, ecological regeneration, and cultural transformation. ACAN is made up of many groups, including these 9 main thematic groups, of which natural material is one. Each group is made up of individuals who want to make change happen. We started the natural material group last year. I will now hand you back to Steph, who will be introducing our first speaker of the night.
Great. So our first speaker is Sarah Lewis. Sarah is Research and Policy Director at the UK Passivhaus Trust. She's an architect and Passivhaus consultant who's been involved in the development of some of the UK's earliest and largest Passivhaus schemes. She's author of best-selling RIBA book on the Passivhaus tool, PHPP, and in recognition of her contribution to low-energy architecture, she was the 2018 European Sustainability and Environmental Woman of the Year. And in 2013, she was listed by the AJ as a top 20 women in sustainable architecture in the UK. So without further ado, I'm going to hand over to Sarah to talk about her myth.
Okay, I'm hoping that that's all just worked really seamlessly and you can, did that work? Can you see? Yeah, excellent. Let me just put a timer on because otherwise I'll run over. Okay, super. So hello, as I was just introduced, so Research and Policy Director at the Passivhaus Trust, and we are super delighted to be at this session this evening discussing this really important topic. My slide's moving on, there we go. I've only got sort of just over 5 minutes. I'm going to try to come in within 8 minutes, so we'll see how that goes. But I'm going to try to, in that time, give a very brief introduction to the Passivhaus standard, just in case some people on the call haven't or aren't so aware with what the standard is. And then I'm going to give you a flavour of some of the Passivhaus projects in the UK which have been built from natural materials. So that's going to be the myth-busting part of the presentation. So let's get started. First of all, Passivhaus. So Passivhaus is a leading international low energy build standard. And I'm just going to pull out a couple of these elements up on the screen just to give you an idea of the breadth of the standard. So focusing on energy balance first. So to explain, on the left is the active approach to coffee making, and on the right is the passive approach. So a typical building is much like a hot plate coffee machine. With the uninsulated glass jug, you lose loads of energy continuously through in a building, the walls, the floor, the roof and the windows. So lots of active heating is then needed to keep that building comfortable. And a passive building, by contrast, is much more like your thermos. So the heat loss is reduced to an absolute minimum, meaning that there's only a very little additional heat then required to maintain a comfortable temperature. Okay, so I'm doing the next 2 slides are going to compare like traditional, typical new build home with a passive house home. So this chart shows you the energy losses on the left through the building fabric and the gains on the right in a typical building regulation home. So in a moment, I'm going to compare that, as I said, to the passive house version. But here you can see that even with the solar gains and the internal gains on the right, so that's the little kind of brown and green bits, the home's heating system, the bit in pink, has to do a huge amount of work just to balance all the losses that the building's experiencing through the fabric. So the fundamental principle of a passive house is to reduce those losses so significantly that the building's heating demand can largely be met by the sun, the people, and the internal equipment you have in your house. And then you just need this really small contribution from the heating system. And a passive house is not actually asking us to radically rethink how we construct buildings, but it's requiring us to do what we already do, but do it with much better quality control throughout the design process and the construction stages, eliminating the performance gap in the process. And passive house is often assumed to be primarily an energy standard, as it does do that part so well. And whilst it is true, passive house delivers very low energy buildings, the standard also delivers much more. So benefits can be observed in terms of the building performance, the climate emergency, health and well-being, people performance, financial benefits, and wider, broader societal effects as well. So I'm not going to spend long on this slide, but I just included it as it does list out all of the key passive house criteria and then highlights whether this is a comfort and health related criteria or energy related. And it's really just highlighting that passive house is about so much more than just energy. And these are the key criteria that have to be met in every single passive house building. And as a result, you end up with a much more comfortable building throughout the year with spaces which are healthy to be in. And when we look at the alternative scenario, which is common in so many millions of buildings in the UK, where you end up with uncomfortable, unaffordable homes which are pushing people into fuel poverty and creating measurable negative impacts on people's long-term health, passive house really is a bit of a no-brainer. So passive house can be built out of any material. The standard is not prescriptive about this. And as such, we have an amazing breadth of material examples with many projects built from natural materials. I did put a call out before this presentation on Twitter for people to shout out their favorite natural passive house projects. And it was literally swamped with suggestions. So what I've tried to do is only show one particular project covering a particular material. So if your favorite didn't make the cut and you're on the call tonight, do pop it in the chat and other people can always Google the project. So in 2018, the Passive House Trust award-winning project was this project by Jura, which was the first application of this product called ACAN, which is a timber straw bale prefab panel system. It's a prefabricated system which is certified as a passive house component, and it allowed for the really rapid and accurate construction of projects. And in this project, the external walls were erected in just 3 days, and the house was watertight in 4 weeks. And then this is up to kind of present day. So this was a 2021 award-winning project by Leap Architects, and it's got cellulose and timber products utilized throughout the project. It includes CLT as an internal finish. I think it was 12.6 tons of wood fiber was used throughout the project, and that really helps to dampen the amplitude of the daily temperature swings that you have in a building, and it extends the time lag of solar heat reaching internal surfaces. So those are really good products in that sense. And the adoption of this all timber construction over a more traditional masonry construction was analysed by the architect for the project, and he found that there was a 40% embodied carbon reduction by choosing the wood products. And then this project by Makar Architectural Design and Build team is a wooden prefab, which they were basically adjusting their SIP construction system. It uses all natural materials, and it was to create a really replicable model that could make passive house homes built out of natural materials really scalable. So it's a really interesting project, and I recommend you have a look at that one as well. And this is a project that I really love by Anne Thorne Architects. They have a number of really lovely, beautiful kind of natural examples of passive house projects. This is a straw bale house in Hickling, Norfolk, with triple glazed timber high performance windows. It was lime rendered and it has lime washed walls, and then it's got its Norfolk reed thatched roof, which accompanies the passive house standard to deliver a really sustainable low energy building. And then this moves on to much larger projects. So it's not just for small buildings. In this non-domestic example, this is the Enterprise Centre, which again is actually down in Norwich. I think I was living down in Norwich actually when this was constructed. It was a very exciting project. The scheme adopts a plethora of really innovative local bio-based materials in the building, including things like flint, reed, straw, nettles, reclaimed oak, plaster, like clay plaster was used, recycled rubber, and the building truly then kind of blends into its natural environment using these really local materials. Many of the materials for the project were actually sourced within 30 miles of the site. So it's a really interesting example of what can be done even at scale. And it really kind of probed the importance and the question about it's not just what our buildings are built from, but it's also how we specify the internal finishes in the buildings and the impact that has on health and well-being as well. So I think that was really interesting. And then this is right up to date. So this is literally a project which is in the design stage at the moment. So this is for Kew Gardens, and it's going to be a really pioneering project. It's looking at using plant-based materials. So it's aiming for the Passivhaus premium standard, which means it's going to have renewables as well. And it's part of Kew's sort of ambitious climate targets. So they're using they're using plant-based construction materials in the project, including things like timber, but also mycelium insulation, which is derived from mushroom roots. So that's another interesting one to look out for. And it's also not just, sorry, I think I'm right on 8 minutes now. I'm just a couple more slides and I'll finish. And it's not just for new build projects. So it's also, we Passivhaus as a retrofit standard. This is an example of a project where the client showed a real commitment to not using petrochemicals, and they only used natural materials. So the whole project was fully breathable. So another one to look out for. And I'm not going to go into this project because I don't have time, but do look up on our website. It's the Entopia building, and that's well underway on site now. And again, they've looked at using bio-based material and using that as a way to make sure that the wall construction when working with existing buildings remains completely breathable, which is an important part of working in a historic environment. And then there's loads of other projects that I don't have time to go into. The Green Building Store have a great variety of retrofit projects looking at different natural materials as insulation and airtightness products on that. So you can look those up yourselves. And on that note, I'm just going to mention a couple of pieces of guidance, and we'll put the links in the chat before handing over to the next speaker. So one's our benefits guide, and the other is the retrofit position paper, which are both available from our website and are of course free, as are all our guides and research papers. And then on a slight side note, that's my girls pictured on the benefits guide there. And we did a retrofit of our house, so it's to the Retrofit standard, and all the paints and things inside the house were completely VOC free, and we used natural wool carpets. So we were really thinking about what we were putting into the building as well as what it was formed from. Thank you very much. I'm sorry for running a minute over.
Sarah, that was brilliant. Thank you ever so much. And the myth that Sarah was busting was can Passivhaus buildings be built from natural materials? And I think she's very clearly demonstrated that that is possible. Do feel free to drop your questions for Sarah in the chat. We've got a Q&A session at the end. So if you've got anything pressing that you'd like to ask, yeah, please drop it in the chat, and we'll flag it at the end. So on to our next speaker is Vari Grant. Vari's an architect and co-founder of the architecture practice Paper Igloo. Vari became a Section 6 domestic energy assessor in 2011 and provides energy consultancy services for other architects. She's a certified Passivhaus designer since 2013 and an RIAS accredited sustainability architect. She's designed many individual Passivhauses and low energy homes, including the renovation of her parents' farmhouse, which won the Saltire Housing Medal in Scotland in 2015. In 2014, she started constructing her own award-winning Passivhaus home with her husband, predominantly from natural materials, which they largely hand-built themselves over a 6-year period alongside running their own practice. So Vari, I'll hand over to you to talk about your myth. Are airtight buildings breathable?
Thank you. I'm just going to share screen just now. Okay, so hopefully you can all see that. That's working. Thanks for that, Stephanie. So the myth I'm going to be looking at tonight is the idea that airtight buildings can't also be breathable, or conversely that breathable buildings can't also be airtight. Obviously, these are not mutually exclusive concepts, and while some of us might be more familiar with the terms separately, I think it's worthwhile looking at what we mean specifically by both of these terms before we look at why it's desirable and beneficial to have both of these things in a construction. Sorry, I'm just, right. At a molecular level, we know that most materials contain a mixture of solid material and air, the balance of which is determined by the pore structure of the material. They therefore allow gaseous molecules to flow or permeate to a greater or lesser extent through the atomic structure of the material and emerge on the other side, or they allow liquid water to be taken up and released. The word breathability is often used to refer to vapor permeability by diffusion, but it should really cover the three aspects shown on this slide, which are more specific and which can all be measured. Vapor permeability is a measurement of the capability of a given material to allow a vapor, like water vapor or any gas, to diffuse through it under a given set of circumstances relating to temperature, vapor partial pressure, and thickness. It's essentially a rate of flow, and so high vapor permeability means that vapor can pass through more rapidly. On material data sheets, you often see this quality expressed in a few different ways, mostly described as resistance. However, we also have two other aspects of moisture management that we need to consider. The first of these is an assessment of how hygroscopic a material is, which is essentially the ability of that material to absorb or adsorb moisture from the surrounding atmosphere. And the third quality we should consider is how capillary open or capillary active it is, which is determined by the way in which the pore structure allows the transport of liquid water through the capillaries as a result of surface tension. This is a complex phenomenon, and the main takeaway point about this, I would say, is just to know that some materials can have a very complex capillary structure, and so their drying potential once wet can depend on this, as well as on surrounding atmospheric conditions. In all three of these aspects, we're really looking to be aware that the properties exist, that they can be interrelated, that they vary between materials, and that in some situations for a retrofit, for example, they can be really significant factors in our choice of new materials that we're adding to existing constructions. Airtightness is a relative term, and as we've described it, in the context of Passivhaus, this doesn't mean our buildings are going to be completely sealed to the external atmosphere. If you think of the building envelope more like a filter, its primary function is to protect us from the elements and to ensure we have a comfortable internal environment, moderating heat, light, air, and moisture, whilst using as little operational energy and embodied carbon as possible to do so. So airtightness is the measure of the resistance to inward or outward air leakage through the building envelope. This infiltration or exfiltration is the uncontrolled leakage of air through cracks, junctions, or other unintended openings, which is driven by differences in air pressure across the building envelope due to both external wind pressure and stack effect. So airtightness is fundamentally different to moisture management, and vapor control layers or vapor barriers are designed to prevent vapor diffusion, whereas the role of the airtight layer is to prevent air leakage through the construction. However, these two strategies can overlap. We can have a material that limits the passage of vapor, and it can also be an effective airtight layer, but the airtight layer will not always stop vapor diffusion, and we don't always want it to. Air changes in a passivhaus are measured differently to permeability in building regulations compliance, which I've noted here. And the last diagram at the bottom is an extract from the Passivhaus Trust Guide on airtightness, which illustrates the relative airtightness of a passivhaus compared to other backstop values. So why would we want to make a building both breathable and airtight? It's currently estimated that about 70 to 80% of building failures are related to moisture in one way or another. I've highlighted some of the risks of unplanned moisture ingress into the construction here. Historical building construction addresses these issues by predominantly using materials that manage moisture and allow a degree of permeability, which along with thickness and mass maintain balance over the seasons. However, traditional buildings can also often be drafty. Some modern techniques and the introduction of certain types of impervious insulation materials, cementitious products, and some plastic membranes do the opposite. And many of these are specifically designed to limit or prevent altogether the passage of moisture in both liquid and vapor forms. So when we aim to achieve an airtight envelope, and so to limit the amount of unintended or ad hoc air leakage through the whole construction of the building, we're also limiting the transportation of the moisture and heat that's within that air into the building fabric in order to protect it. As we can see in this diagram, bulk air movement can carry a lot more moisture into a building fabric than can be transported via vapor diffusion alone, and any unintended moisture within the fabric can lead to interstitial condensation if it can't escape. So this illustrates the importance of keeping the airtight layer continuous and intact. However, it's very important we also recognise that whilst we want airtightness, we also need a well-ventilated interior environment that can successfully deal with pollutants such as VOCs and internal moisture sources that cause or increase humidity. The images at the bottom all show examples of the damage that moisture ingress can cause. The first of these was taken during investigations into an existing flat roof failure, which had featured several impervious layers, including the insulation, with no way for any moisture within the construction to escape. And the remainder shows some other symptoms of moisture-related issues, both internally and externally. So yes, we can have a building that's both capable of successfully managing moisture and being airtight to Passivhaus levels. I'm sure we're all familiar with the classic woolly jumper versus oilskin jacket analogy, which then concludes with a sophisticated solution of the Gore-Tex jacket, delivering both warmth in the wind and allowing perspiration to escape from your body. In other words, airtightness with moisture management. In buildings, the same principle can be applied with materials that can successfully create an airtight layer and adequately manage moisture. As it is impossible to eliminate the potential for moisture to enter into or form within building components over the whole life of a building, it's critical that we design construction which, in the event of unforeseen moisture ingress, can allow the building fabric to dry out as quickly as possible. To facilitate this, we need to design the build-up on the warm side of the insulation with a higher vapor resistance compared to that on the cold side, and this helps to allow any moisture that may form within the construction to safely dry to the outside. But for constructions that have difficulty drying to the outside, we can use membranes that have a variable diffusion resistance. These membranes can have a place in locations such as below warm flat roof constructions with impervious layers on the outside of the construction, or some lightweight constructions where we might experience backwards diffusion, which drives vapor towards the inside of the construction. And due to their variable properties, these types of membranes can also cope with unanticipated moisture intrusion within the build-ups. If we make a building that can manage any moisture that may arise within the construction and is also airtight, we stand the best chance of reducing energy consumption and costs, creating a healthy indoor internal environment, improving thermal comfort for the building occupants, limiting the possibility of condensation and mold formation, and ultimately delivering a safe and durable construction. So how do we do it? In the context of Passivhaus and natural materials, how do we marry our desire for low carbon materials with Passivhaus performance? There are three main categories that we can of material we can achieve these moisture management and airtight qualities with. We can use membranes on the internal side of our natural material build-ups, and there's at least one paper-based variable diffusion membrane on the market currently, which I've shown here, which also has a matching paper-based airtight tape. Membranes are advantageous because they are thin and they can be cut and folded easily around other components like joists. But they can be more easily damaged on site than other options, and a lot of them do contain plastics in one way or another. We can also use boards or sheet materials, and probably one of the most commonly seen is OSB, but there are quite a few other wood-based boards that are from sustainable sources with low formaldehyde and that can achieve a reliable airtight finish. Boards are durable and can also perform a structural purpose, but they are thicker, less easily adapted to difficult shapes in older buildings, and they can conceal issues once they've been installed. And finally, we can also use plasters, and instead of gypsum-based products, we can use clay or earth or lime-based plasters. Plasters can be advantageous in that they're adaptable to different shapes, such as curved surfaces or curved edges, and they can replace membranes and tapes over large areas. However, it is a wet trade, so that has an impact on sequencing. And in addition to these internal components, many bio-based natural materials have similar relevant properties that allow us to achieve adequate moisture management throughout the whole construction. Materials such as straw, natural fibers like wood, jute, hemp, and cellulose, building blocks like clay or hemp, and so on, can all help to manage moisture and also protect from the risk of interstitial condensation by allowing vapor to pass through them. And many of these materials are also hygroscopic or capillary open with a high drying potential. And externally, vapor open renders and other bio-based cladding materials can all protect from the elements and yet allow any vapor to escape to the atmosphere. So finally, I just thought I'd show some images from the construction of my own Passivhaus home, which my husband and I built, which was a twin wall timber frame with wood fibre insulation. So these photos show some of the sequence of the frame building and the hand-placed wood fibre bats going into the walls, the external layer of rigid wood fibre, as well as the unfinished timber cladding. This building has an air tightness of 0.2 air changes and is really comfortable and stable internal environment. Natural building materials and systems are eminently capable of achieving the Passivhaus standard, and they also have other wide-reaching benefits such as circularity, low embodied carbon, better occupant health, and they can be used to create regenerative design. Thanks very much. I hope I didn't take too long there.
No, you definitely didn't take too long, Valerie. That was incredibly informative. And I think I will be going back and watching the recording. So thank you very much. That was really interesting and so much information. And the diagrams are brilliant. Thank you very much.
Thanks. I hope I didn't speak too quickly as well.
No, it's great. So just moving on to, as Barry kind of mentioned, the health and well-being dimension of Passivhauses, I'm going to introduce Sam Foster. So Sam's an architect with a strong interest in beautiful, low-energy architecture constructed from non-toxic materials to create healthy environments. Sam qualified in 2005, and after working with leading ecological practice Gaia Architects, he ran his own practice between 2011 and 2020. Sam has worked as research assistant at Robert Gordon University and associate professor in architecture at Heriot-Watt University. He's now a part-time development officer with Rural Housing Scotland and a part-time labourer at Scottish Wood. So can I introduce Sam, whose myth is a passive house always healthy? Thank you, Sam.
Very much, Steph. Let me just do this with the presentation. Does that look okay? Brilliant, thanks very much. Hi, Steph and Barry, thanks very much for asking me to come along and contribute to the event this evening. It's entirely possible for a passive house to be built from barrels of nuclear waste. As long as we get things like the form factor, summer shading, U values, etc., right, we can get that badge, but it's not very good for us or the planet, is it? And obviously that's an extreme example, but as we strive for energy efficiency, we've largely forgotten about health. And we continue to build our homes from materials that we know are really bad for us and for the planet. I mean, look at the back page of this month's Passivhaus Plus magazine and the products that are being promoted there. There's also an assumption that in Passivhaus, the MVHR system will take away all of the pollutants, but that's not quite the case. We know that the conversation in Passivhaus around health tends to be focused on temperature and carbon dioxide, and Passivhaus is very good at achieving some things, but there's also quite a lot of research by organisations such as MIRU, Macintosh Environmental Architecture Research Unit at the School of Art in Glasgow, that show that the carbon dioxide levels in passive houses can be much higher than anticipated. And that also shows the value of building performance evaluation and post-occupancy evaluation. In the 1930s, we had about 50 materials as architects to choose from. Today, we've got more than 50,000, less than 3% of which have been tested for their toxicity. In the UK, we are spending more than 90% of our time indoors. There's a survey done in 2017, I think they said it was 92%. So we're spending lots of time indoors. Indoor air is often up to 10 times more polluted than outdoor air. Male fertility has reduced by 40% in the last 25 years. It seems likely that these things are linked, but like that frog in the boiling pan of water, we are poisoning ourselves out of existence, and we're completely oblivious to it and the warning signs that go with it. We will not address the climate, biodiversity and health crises solely by building everything to Passivhaus and to EnerPHit standards. They are important, but we need to go further. We need to move from using toxic materials to using materials and components that are made from natural, non-toxic ingredients and that are good for us and the planet. So that means moving away from things like this and anything made from fossil fuels. It means reducing our use of things like concrete and sand, everything which is extractive, things like highly glued timber boards, and even gypsum plaster has a major environmental impact. We need to move away from using so much steel as well. Steel is much more recyclable than other materials, but we do need to reduce how much we use and move towards renewable materials. Because with the exception of sand, all of those things that I've just mentioned are fairly toxic. Some of them are incredibly toxic. And there are over 350,000 chemicals used. Sorry, there's 350,000 chemicals on the market today. A lot of those are used in building materials and internal finishes. And if you go onto a manufacturer's website, you can generally download a material safety data sheet that tells you what's inside that component, that material that you've got. Except manufacturers don't have to tell you all of the ingredients. Through copyright, they're allowed to tell you some of the, or they're allowed to withhold the information on some of those chemicals. The result is that buildings are being built from synthetic materials which off-gas significant quantities of different chemicals into the indoor environment. And we, as the occupants of these buildings, are exposed to a chemical cocktail of synthetic ingredients. And there's nothing we can do about it unless we use natural materials. Our physiologies, our human physiologies, have been developed over, I don't know how many, 100,000 years, 200,000 years, 500,000 years. These chemicals that we're exposed to have only been in existence for the last 60 or 70 years, and we are just not equipped to deal with them. And that's partly why there are increases in cancer, for example. There isn't a single scientist in the world either that knows what the effect of these chemicals is as a cocktail. Scientists know what individual chemicals would do to us, like formaldehyde, for example. That's carcinogenic, everybody knows that. But when you mix formaldehyde with flame retardants that are in all of our sofas and with the fragrances that we've got plugged into our plugs, nobody really knows what happens to our bodies and what impact that has on us at all. So this is what we need to do. We need to move from these synthetic non-renewable materials to renewable materials like timber, homegrown, untreated timber. And we've got a fair amount of that in the UK. Not as much as places like Sweden, Germany and Austria, but we've got a fair amount. And the more we use and the better we use it, the better will be the replanting of the species that we replace them with. Everyone's used to seeing timber frame. That's a good thing. A lot of you will be used to seeing things like Brettstaple, massive timber like Brettstaple or cross-laminated timber and wood fibre. And we've had some really nice examples. We have seen passive house projects built from rammed earth. We've seen straw bale houses. And we saw a lovely example of George's Eco-Cacom project earlier on with the prefabricated straw bale panels. But there's hemp and hempcrete, and people are building passive houses out of this and then insulating parts of their buildings with jute and sisal and plant-based materials. But there are also really interesting materials like cork. And this fantastic project down south, I say down south because I'm up in Scotland. This fantastic project down south was built almost entirely from cork, apart from a bit of cross-laminated timber. And Sarah earlier on mentioned the use of mycelium in the project at Kew Gardens. And mycelium is becoming a really common material for boards and for insulation products. All of those things I've quickly rattled through are non-toxic. Fair enough, there's a little bit of glue in cross-laminated timber, but it's a very, very tiny proportion. It's nowhere near the amount of petrochemical product or chemical products used in PIR insulation, for example. We also have to really think seriously about our internal finishes too. And that's not just the flooring and the walls and the paints, but it's things like our internal furniture as well. So when we're developing our strategy for our construction, it's the internal finishes that tend to off-gas most into the indoor environment. So what we finish off our buildings with is really important. Now, a couple of things that I haven't mentioned, which I'll mention very briefly, are solid floors. So I tended to use limecrete and foam glass or LACA, which aren't plant-based and aren't renewable, but have much lower embodied energy and toxicity than concrete and plastic insulations. So benefits, let's quickly run through those. Yeah, there's quite a few benefits of moving to natural materials, aren't there? They've got lower embodied energy and CO2, which means less pollution is created. The waste from natural materials tends to be compostable. I did a straw bale house a few years ago, and the occupants spread the remaining construction modules of straw bales on their garden. Natural materials are made of fewer materials, which means they're easier to take apart usually and recycle or reprocess at the end of their life. natural renewable materials are just less toxic. They have fewer chemicals in them. They have chemicals, they're full of chemicals. Wood is full of formaldehyde, but it's at a much lower level than synthetic products. And yeah, they can be taken apart. I think I've already said that. They can be taken apart really easily, because the way you put natural materials together is very different to the way you put synthetic materials together. So that's lovely. We've built all these lovely buildings. You build these lovely buildings from natural materials, and then the hard work begins, because we hand these over to occupants, and this is where our journey with our clients must continue. It's imperative that we encourage the clients that we work with to maintain this healthy environment. So encourage them to consider reducing the use of highly chemical detergents, fragrances, cosmetics, and either use less or use different materials, because the occupants will have a huge impact on the buildings that they occupy. Up in Scotland, we have the RINAS and its environmental statement, which is maximum architectural value, minimum environmental harm. They've had that for years, and we are not following it. It's about time we did, I think. Okay, that's me. Thanks very much, Steph.
That's brilliant. Thank you very much, Sam. I think we've got lots to think about when we're thinking about our own homes and our health and well-being. So that's really great. Thank you very much. We've had loads of really great questions come in from the chat. So I'm conscious we're a few minutes over our allocated time for presentations, so we might just jump straight into that. And I'm going to start off with one for Sarah, and it's: do you see an increase in passive houses being built by natural materials at the moment?
It's really difficult for us as the trust to know exactly what's happening, because we only know about the projects people tell us about. But we're certainly seeing, just across the industry in general, a lot of clients becoming more interested in certainly embodied carbon, which is then pushing more natural materials forward on the agenda. And I think also some of the things in the industry which have come out around Grenfell and sort of product declaration information, I think has affected what clients are taking as just kind of standard specifications and making people question what they're doing. So certainly when we're looking at some of the larger clients who are maybe procuring like new social housing, I do feel like we are seeing more discussion around the actual materials that these are going to be built out of, rather than just looking at performance specifications in terms of energy performance. So you get the feeling the industry is moving that way. I'd like it to move that way quicker probably, but I think everybody on the call probably would. But I think, yeah, it feels like there's been some good progress with the discussions that we're seeing in the moment.
Great, thank you. And one for perhaps Sarah and Vori. Are there any better natural materials to build a passive house from, would you say? Any particular favourites?
So, well, I would say not better, but just specific to your project, which isn't a cop-out, because genuinely there are so many other factors that go into your decision-making process when you're choosing materials, that I think that, you know, what's appropriate in one location isn't necessarily appropriate in another. So not every site is going to be suitable for straw bale, for example, but that doesn't mean that it's better or worse than, you know, hemp block or anything else. So that would be my view on it, that there would be so many other factors that would dictate your choice, that I don't have a specific favourite. I mean, we've done a lot of projects with wood fibre, but so I'm more familiar with that, but I don't have a favourite per se. What do you think, Sarah?
Yeah, I mean, I agree. The projects I've worked on, probably mostly wood fibre. We've also like worked on clay block using lime internal plasters as the airtightness. When we did a project which was a social housing project, so that was, you know, quite a big site compared. It wasn't like a one-off project, so that was a local authority looking at trying to do something where they were incorporating natural materials and really prioritizing internal health and well-being for residents, which was great. And I think actually this almost ties into some of the other questions which have been coming up, which have been about retrofit, because it's like, as has been rightly pointed out, 80% of the buildings which are going to be around in 2050 have already been built. So we have a huge amount of work to do in getting those buildings ready for a zero carbon future that we're all sort of envisaging. And part of that, getting those buildings ready for the future, has to be some level of demand reduction in terms of how much energy those buildings need. And that really is going to mean that we're going to be retrofitting them in some way. And there's lots of debate about how far we need to go. And I think that there's different levels, but those natural materials really form an important part of our toolbox when we're looking at retrofitting historic buildings or existing buildings, because we're often looking at doing internal insulation. And that, as Sam was pointing out, is particularly important when those materials are literally inside the building. And I think there's different choices that people would make about what internal insulation is most appropriate for a project. And it might be based on how much, as like Mary was talking about, like how like hygroscopic materials are, how like permeable they are. And that will depend on the existing fabric of the building and how it performs. So it gets quite technical actually, and you need quite building physics sort of minded architects to be involved in those projects, because you have to get into how the fabric performs and what materials you can add to those. And also there's different performance of those materials in terms of thermally. So you might need more insulation to get the same value out of different materials. And again, that might play into what materials you choose to use. So there's loads of different kind of interplaying, factors that would
That was a great answer. That was a really great answer to a very complicated question. So thank you very much, Sarah. Barry, did you have a point?
I was just going to say, I think on the retrofit topic as well, it's for me, there is a balance between making a safe decision in terms of the building health and the occupant health about how far you go with the insulation versus achieving a specific energy standard. I mean, I'm absolutely in favour of Passivhaus standard, but I think that for some retrofit situations, it's got to be a balance, because the last thing that any of us want to do is create a problem that we're, just pushing down the line, basically. So I think but for me also, that's where natural materials can really come to the fore, because they have all of these properties. You can create a construction that works in a much more similar way to a traditional moisture management kind of construction, but that's also airtight and therefore warm and comfortable, and all the benefits that come with that.
Sam, I'm going to bring you in here into the retrofit, natural materials and debate, because I think you've got a lot to add.
Yeah, we've looked extensively at how to retrofit buildings and to try and achieve NFIT standard. And when this has been on solid walled properties rather than cavity, and it's been very difficult. And as Vary just mentioned, we've moved on the projects that I did work on, we moved away from aiming for NFIT, because obviously the more insulation you put on the inside of a wall, the cooler you're making the inner surface of the solid wall, like the brick or the stone, so the greater the risk of moisture building up over a period of time. And we just couldn't get the sums to stack up. And that was working with people like Mike Y and Ecological Building Systems, who got Woofy, that wonderful piece of software to do the prediction of moisture buildup. And I mean, as architects, we are dumb creatures. We really are. We're relying on this predictive software to hope that we're doing the right thing. And it got to the point on one project where we were arguing about aiming for a U value of 0.0312 or 0.0305. And in the end, we just thought, we're going to actually reduce the U value to 0.4, which is more heat loss, which is a terrible thing to admit. But we did that so that we had enough heat going to the surface of the wall, so that we just didn't have that buildup of moisture. And that was using a product called diathanite, which is a cork lime plaster. Choose your installer for diathanite wisely, people. That's all I want to say on that.
Great. I have one more question about kind of down the contractor route. So we've had one come in saying, do the panel think natural materials can prove a barrier to traditional contractor procurement routes rather than smaller scale or self-build projects? Would anybody like to answer that?
Well, I think, I mean, my experience is all kind of residential end of the spectrum, but I think, you know, once you have a conversation with a contractor about the materials they're using and what that means for them in terms of safety on site and the health of their workforce and so on, I've not found anyone yet who's not on board with, you know, a safer, more healthy approach. So we've certainly not found it a barrier, and working with people who've, you know, literally gone from all their other projects or Celotex or, you know, some other kind of phenolic insulant to then saying, okay, well, it's all now cellulose and wood fiber and things. They're like, okay, you know, that's not been a sort of a huge difficulty with that.
Yeah, I would agree. I mean, I think that we can see that there's large scale projects being delivered with natural materials. So clearly, like, the procurement routes exist for people being able to like source those materials. The project I mentioned earlier, where we went for the clay block and with the lime plasters, you know, it was a design and build contract, and the first suggestion from the contractor on that project was actually a SIPS panel using like a Celotex type product. So that was their known supply chain. We were like, well, how about we do this instead? And they were like, yeah, let's do that. And that was the route that was taken. There wasn't resistance to it. I feel like people are quite open to these things, and the supply chains are, some of them are not as developed, of course. So you can go to any builder's merchant and pick up some Celotex, but on large projects, they're going to be placing orders for these materials. So I don't see it as a huge barrier.
There's a lot of direct comparison in the use of natural materials with synthetic materials. I mean, putting in insulation, for example, is just as easy using sheep's wool or flexible wood fibre as it is putting in rock wool or fiberglass, which a lot of people still do. And people, usually it's not the managing directors who are the happy ones, it's the operatives, the ones who have had to install it, because they don't go home itchy as anything at the end of the night or at the end of the day. They're happier.
Yeah,
and healthy,
absolutely.
which is wonderful.
I mean, when we were building our extension, we used wood fiber, and I was like, there was a point where we were doing it during COVID and materials where there was some issues, and my husband was like, should we just get some rock wool? And I was like, no, because we're doing it ourselves. And I was like, if I have to touch the rock wool, I'm gonna cry. No, we have to wait for the wood fiber to get here, which we did. But it was like, as the installer, it's just so much nicer to work with. So there's genuine benefits.
Yeah.
Brilliant. That's great. I'm conscious of time, so I think we're going to have to wrap up there, although there are a few more questions, and I'm just going to touch on one that says excellent presentations, and I love the idea of mycelium, but I haven't seen evidence of it being common in the industry. And I'm going to use that as a kind of segue into ACAN Natural Materials and the group that we currently run. So we have a Naturals Materials Masterclass, which we run kind of every month or every other month, interspersed with events like this, such as myth busting. And our next event in March is on cork. So you saw in Sam's presentation, he had that beautiful house by Matthew Van Howland, and Matthew will be talking at our cork event on the 10th of March. So if you are interested in using natural materials and kind of gearing up your arsenal of natural material knowledge, please come to the cork event. It'll be really, really, really informative and really interesting. And I'm going to use this opportunity as well to plug our audience survey that we have. So we're currently trying to understand the main barriers to natural materials, and I believe Jana is going to post that in the chat box now. So if you're interested in helping us understand what the barriers are and what resources we can produce that'd be most useful to you to overcome those barriers, please take part in that audience survey. Everything and all of the kind of comments that people write are really useful and really helpful. So a couple more things. ACAN and Natural Materials will be at Future Build. We've got a bar takeover, live demonstrations. We're going to have some great samples of really cool and wacky natural materials, as well as more kind of mainstream ones. So if you are coming to Future Build, it's the 1st to the 3rd of March, I believe. Do come and say hi, check out our stand and the bar, and yeah, stick around. We've got some talks going on as well, so it should be really interesting. And if you, and then the other thing I'd like to say is we've got a ACAN Natural Materials working group. So as Aurora said at the beginning, there are 9 working groups. We are the Natural Materials one, and if you'd like to join us, you can email us at naturalmaterials@architectscan.org, or there's a WhatsApp link, joining link also, that's getting posted in the chat now. So we just want to say there's going to be a follow-up party bag roundup of this event with information on the speakers and further resources. So do watch out for that in your inbox. It should be coming over the next couple of days, and it will give you some opportunities for further reading on Passivhaus and natural materials if you're interested. And I just wanted to say a big thank you to all of our speakers who've been here this evening. It's been really interesting and informative, and I'm going to watch this again because I think there was so much gold that was spoken about. So thank you ever so much, and thank you everybody for coming. I've had a really good turnout today, so yeah, thank you, and we hope to see you either at Future Build or at our Cork event a week later. So that's all from us. Thank you very much.
Thanks very much, Stephanie.
Bye.